Good morning, good afternoon, or good evening. This is Mr. P signing in. Today we're going to talk a little bit about our notes, guided notes for section 11.6, the surface area and volume of spheres. So the surface area of a sphere, this is truly one of the craziest things that I've ever heard in math. It's absolutely true, though, is that a sphere has a radius just like a circle does. And if you imagine this circle that goes around here, like the belt that fits around there, it would have the same radius as the sphere. And it turns out that the surface area of that sphere is actually just 4 times the area of that circle. Now, you'd think there would be a really neat picture to just show you how that works, but it turns out that no one has yet found a very simple, clean picture proof of what it is that makes it that so 4 circles are equal to the surface area of the sphere. The volume of the sphere is another formula you just kind of remember. It's 4/3 times pi r cubed. It's kind of a weird thing. Basically what it is that a sphere has 4 times the volume of the secret cone that fits in the top or bottom hemisphere. That is, if I had a cone that had the same radius of the sphere and whose height was actually the same as its radius, both of the cone and the sphere, is that 4 of these make up a sphere. So let's find the surface area of these spheres. Well, again, let's find the area of just this circle. Now, the area of a circle is pi times radius squared, which in this case is pi times 5 centimeters all squared, which is 25 pi centimeters squared. And like I said, the surface area of a certain sphere is 4 of these. So if we multiply that by 4, you get 100. 100 pi centimeters squared is the surface area of that sphere, which is about 314 well, you can do 100 times your pi, 314.159 centimeters squared. Very good. So let's find the surface area of this sphere. So again, you find the area of that circle, which is pi times the radius, which is 4.5 inches, because the diameter was 9 inches. And that's going to be all squared. I don't know what 4.5 is squared off the top of my head. 20.25, which is 20.25 pi inches squared. But 4 of those are what fit around our sphere. So we do 4 times 20.25 to get 81 pi inches squared. Is our surface area, which is approximately, multiplied by pi, 254.469. inches squared. Okay, so this is a little bit different because here's the fun thing, is that I only have half the sphere. So let's start with this. So diameter is 2 feet, so the radius is 1 foot, which means the area of that circle is 1 pi times 1 foot all squared, which is just pi feet squared. Now 4 of those would fit around a full sphere, but notice that this is only half a sphere, so half as many spheres are going to fit around it. So that's 2 times pi feet squared, which is 2 pi feet squared. Now, that's not quite the full story, because what we've just done is we've gotten the outside, yeah? The outside of the sphere is 2 pi feet squared, but now that it's been cut in half, part of its surface area is this bottom circle, right? Like that's just as much the surface as the part around it. So we have to add on that area, which is pi feet squared, we already figured out. So it's 3 pi feet squared. Now, some of you might have noticed, oh, by the way, that's approximately 9.425. Some of you might have noticed already that that was going to be 3 times the volume, the area of a circle, because it's going to be 2 for the part that goes around it than the one that goes on the bottom. That's wonderful. But I took us kind of a longer way because I wanted to make sure everybody saw where it came from. So find the diameter of a sphere with a surface area of 144 pi square centimeters. So remember, the surface area of a sphere is equal to pi, 4 times pi times the radius squared. And now we know the surface area is 144, and that's going to be equal to 4 times pi times radius squared. Oh, that's 144 pi. That makes my life a lot easier, because now I can divide both sides by 4 pi, and the pi's will divide out, and 144 divided by 4 is 36, which means 36 equals the radius squared. Take the square root of both sides, and r equals plus or minus 6 is a distance, so it's 6 centimeters, because it was square centimeters. And the diameter is just twice that, so 6 times 2 is 12 centimeters. Boom. Now the volume again, folks. So how I do the volume here is, again, I want to imagine finding the volume of the secret cone that fits inside here that has the really special property that its height is the same as its radius. So the volume of that cone would be 1/3 times pi times radius squared times radius, because that's the height, which in this case is 13. So it's 13 times 13 squared, 2197. And if you divide that by 3, you don't get a nice number. So we're just going to leave it like that. So that's 1/3 times pi times 13 squared times 13, which is 2197 over 3 pi centimeters cubed. And now the thing is that 4 of those cones are going to fit into that sphere. So I'm going to multiply this thing by 4, which gives me the absolutely horrible number, 8,788 thirds pi centimeters cubed. And I have an assumption that they would really like us to get that as an approximation. So we divide that by 3, multiply it by pi, and I get 9209.772. 9,202.772 centimeters cubed, and that's what I would leave it as. If you absolutely hate that cone way of doing things, let's do it just through the formula. The volume of a sphere is 4/3 times pi times the radius cubed. And the radius in this case is half of its diameter, which was given to us, which was 15. 15 divided by 2 is 7.5, I believe. Let's just make sure I don't mess that up. Yeah, 7.5. So 7.5 cubed. So if you do 7.5 to the 3rd power, I get a terrible number, but if I multiply that by 4 and divide it by 3, I get 562.5. So the volume is equal to 562.5 pi inches cubed, which, if you want an approximation, as I am assuming this also does, is 1,767.146 inches cubed. Whoosh. Find the volume of a sphere with a surface area of 4 pi inches squared. Ooh, clever. Because the surface area is equal to 4 pi r squared. We now know that the surface area is 4, so 4 pi is equal to 4 pi r squared. Divide both sides by 4 pi. Oh, also gone, which means that 1 equals r squared, which means that r equals 1. So find the volume of the sphere with a volume of, or a radius of 1. So again, I imagine this cone with a radius of 1 inch and a height of the same. And the volume of that cone is 1/3 times pi times the radius squared times the height, which is the radius again, which means that that's really just pi thirds. And it turns out that 4 of those cones fit inside of the sphere that you could put around it. Having a hard time drawing my sphere today. You get the idea. And so we're going to find the volume of the sphere is equal to 4 times pi thirds, which is 4/3 pi inches cubed, which if you actually do 4 divided by 3 times your pi is 4.189, about 4.189 inches cubed. Find the volume of the composite solid. So it's kind of hard to see, but what's going on here is that you've got this cylinder and you've created a divot with these 2 hemispheres in it, which really is just a whole sphere. So let's start by finding the volume of the cylinder without the spheres even taken into account. So the volume of the cylinder is going to be equal to pi times the radius, which is given to us, squared, times the height, which is 15. So 6 squared is 36 times 15. That's 540 pi feet cubed. But notice that you've carved out these 2 hemispheres, which, if we put them back together, would be a full sphere. So we've got to find the volume of the sphere and take that away from the volume of the cylinder. Now that's 4/3 times pi times radius cubed, which is 4/3 times pi times the radius, which is 6 cubed. 6 cubed is 216 times 4 divided by 3, and I got 288 pi feet cubed. Subtract these, and I'm going to do this by hand. See if you can beat me with your calculators. Again, not literally. Please don't hit people with your calculators. 2, 1, nope, got to borrow again. 2, you guys have definitely beat me by now. Because 3, what's that saying? So 4, 13, 12, 11, 10. Should have just used my calculator for minutes. 252. I'm going to double check because that got weird. 540 minus 288 is 252. It sure is. 252 pi feet cubed is the volume of this weird cylinder that I have no idea what you would use this thing for. Like an hourglass, but nobody bothered to drill a little hole that goes from there to there. I got nothing for you. Anyway, I do have the surface area and volume of spheres for you. If you have any questions, please send a message to your instructor. This is Mr. P signing off. Until next time, have a great and wonderful rest of your day.